I'm going to start off by asking you a question. By a show of hands, how many of you have ever gotten sick from eating something or know someone who has? Most of us have, and it's usually an unpleasant experience we never forget. Foodborne illness is a major problem worldwide. Salmonella infection is one of the most common bacterial causes of foodborne illness. In fact, the World Health Organization classifies salmonella infection as one of the top 4 leading causes of diarrheal disease on this planet. Salmonella infection occurs by consuming contaminated food or water and is common in developing countries where people may not have access to clean food or drinking water. Iron is an essential nutrient for both humans and bacteria, like salmonella. Salmonella use iron for growth, while humans use iron mostly for red blood cell synthesis. Despite the importance of iron in the human body, iron deficiency is the #1 most common nutrient deficiency worldwide. The current treatment for iron deficiency is supplementing with iron pills or adding iron to foods like wheat flours. This treatment has limitations, though, since only 10% of supplemented iron is actually absorbed. The other 90% of iron continues through the digestive system and ends up in the large intestine. This presents a potential problem since the large intestine is also a major site of infection for salmonella. My hypothesis is shown on the right. In an iron-deficient diet, there is no iron available in the large intestine for salmonella to colonize. In contrast, with an iron-supplemented diet, there's plenty of iron available for salmonella to use, which may lead to a more severe infection. To test my hypothesis, I used an animal model where mice were fed identical diets, with the only difference being that one was iron-supplemented while the other was iron-deficient. After 1 month of feeding, I measured the amount of iron in the large intestine of these animals, and I found that the iron-supplemented mice had over 16 times more iron in their large intestine than the iron-deficient animals, who had virtually none. After iron supplementation or deficiency status was established, half of mice in each diet group acted as a control, while the other half were infected with salmonella. Shown here are 3 important measures for indicating severity of infection. For all figures, the garnet-colored bars are representing the iron-supplemented group, while the gold-colored bars are representing the iron-deficient group. The control animals are shown to the left of each figure, while the salmonella-infected group are on the right. Focus your attention on the salmonella groups in each figure. Starting on the figure to the left, we can see that the weight of the spleen was significantly increased in the iron-supplemented group compared to the iron-deficient group. This indicates a more severe infection. Next, the figure in the middle illustrates the weight of the cecum, which is a specific portion of the lower intestine. And it is known to decrease in weight with severe infections. In my experiment, I found that the iron-supplemented group had significantly lower weight of the cecum than the iron-deficient group. Finally, the figure on the right shows the change in body weight over the course of the infection. I found that the iron-supplemented animals lost over 30% more body weight than the iron-deficient animals over the course of the infection. Collectively, these results confirm my hypothesis that iron supplementation increased the severity of the salmonella infection. These results are important because areas with high rates of iron deficiency, where we supplement with iron to correct that deficiency, tend to overlap with areas with high rates of salmonella infections. We need to weigh the benefits of iron supplementation with risk of infection in countries where these infections are common. The ultimate goal would be to evaluate an alternative iron supplementation strategy where we can use different chemical forms of iron that are unavailable to bacteria, such as salmonella. Thank you.